Okay, so we're back and we're going to talk about the rest of chapter 8, which is all about dividing. So there are going to be 3 different situations that we're going to talk about with dividing. And the first one is when we're dividing a polynomial. So remember, polynomial means many terms. So really this means any number of terms, by a monomial, which is just one term. So this is what we're going to talk about here, which is the simplest type of division that we have to set up. Only happens when we have just one term that we're dividing by. So let me just show you what it is first, and then we'll go back and look at the steps I have written here, which are a little bit wordier. So if I look at example 10, I can see that here's my polynomial in the parentheses. 3x to the 5th plus 6x to the 3rd minus 18x squared plus 12x. That polynomial is going to be divided by 3x. So what I'm going to do, one way, oops, that's not what I want, is it? Another way this could be written is 3x to the 5th plus 6x to the 3rd minus 18x squared plus 12x divided by 3x. Okay, that we could also write this division that way, either way. But what we're going to do so that we can actually work with it is we are going to write this so that my top polynomial is going to be written as separate terms, each separate term written over that 3x. So instead of one big fraction like this, it's going to be split into separate fractions. So 3x to the 5th divided by 3x, and then 6x to the 3rd divided by 3x. Minus 18x squared divided by 3x plus 12x divided by 3x. So now I can really clearly look at dividing each of those terms by that 3x. So up here I have a little reminder here that the first number is called the dividend, the first number, or in this case expression. What it's divided by is called the divisor. I'm not going to quiz you on that or anything, but I just have that there because in number 1 here I use those 2 words, so I want to make sure you know what's what. So I'm going to write each term of the dividend of that polynomial as a fraction with the divisor as the denominator. So that's what we did here, right? My divisor is 3x, so I wrote that as the denominator of each of those fractions. Then I'm just going to use exponent rules to simplify each term. So if I just look at one part, let's say over here I just rewrite the first fraction, this right here is a fraction that I would have seen in chapter 7, okay? So, I'm just going to divide the coefficients, and then I use the quotient rule here, which tells me that when I'm dividing like bases, I subtract the exponents, okay? So 3 divided by 3 is going to be 1. X to the 5th over x is just x to the 4th. That's how I simplify that first fraction. Then I move on to the second fraction. 6 divided by 3 is 2. X cubed divided by x is x squared. 18 divided by 3 is 6. It's negative. I already had put that in there. X squared divided by x, 2 minus 1 is 1, so it's just x. And finally, that last term is plus 4. When I look at this, none of these terms are like terms, so they can't be combined. And it is already in standard form, highest exponent down to lowest. Okay, so we really haven't done anything super new in this problem. We've just written this under each term, which really we've done before, right? When we put things into y equals mx plus b form, if we had to divide by something in front of the y, I told you to make it easier, write it separately under each term. That's all we're doing here. And then we're using those chapter 7 exponent rules to simplify. Okay, another example here, same idea. So we're going to rewrite it with each term separately over that divisor. Okay, so 15x to the 4th over 2x squared negative 10x to the third over 2x squared, etc. All four of those terms. Now a couple things are going to come up in this one that didn't happen in the last one. Just some little specific situations that I want to look at. So the first one is that if I look at the coefficients of that first fraction, 15 and 2, 15 divided by 2 does not come out to an integer. In the last example, every one of those divisions came out to an integer. Here it does not happen. So if that happens, you can leave it as a fraction, or you can change it to a decimal if it's a decimal that ends. If it was something over 3 and it's going to be a repeating decimal, we don't want to do that. If we have something like this, then that's fine. So some examples are this first term, I could, when I am going to simplify my x's, 4 minus 2 is 2, so I could write this as 15 over 2 times x squared. I could write it as 15x squared over 2, those always mean the same thing, or I could write it as 7.5 times x squared. Any of those is equally good, okay? I tend to leave them as fractions myself, but any of those is okay. So I'm going to have here 15 halves times x squared. Now in this next term, 10 divided by 2 does just become 5, and I just have x because 3 minus 2 is 1. And then here, again, remember I have a 1 in front of this x squared, so 1 divided by 2, again, you could either leave it as 1/2 or you can put 0.5. X squared divided by x squared cancels out, so I don't have anything there. And then the last one, 6 divided by 2 is 3. Now when I subtract this, 1 minus 2 is going to be negative 1. So I can leave this as my answer, or I can go ahead and rewrite that last term knowing what we found out in chapter 7 about negative exponents. I can write it as 3 over x to the first. Either of those is fine. And as we're looking at this, there are no like terms here that I can combine. X to the first and x to the negative first are very different, and it's in standard form. If I look at the exponents, I have x to the second, x to the first, x to the 0, x to the negative 1. They do go down in order. Okay, so we set it up like this when we are dividing by a monomial, dividing by something that just has one term. We can write it like this. Okay. Now, when we have a situation where what we're dividing by, our divisor, is more than one term. So if we look at example 12 down here, my divisor has more than one term. In that case, I cannot divide like that, and we have to do long division with polynomials. Okay, so that's sort of our second category, right? So either we're dividing by a monomial, and we can do it that easy way where we write them as fractions, or if we're dividing by something with more than one term, we're going to look at using long division. So we're going to start out by reviewing regular long division with integers. So we'll review that because the process is the same, it's very similar, I should say, between the two. So let's look at this, and let's start out by just thinking about how we set it up, right? So our dividend, the first number, goes under the square root sign, and our divisor, what we're dividing by, goes outside the square root sign. And then the first step is, we can say it's to divide, okay? And what we're doing is, in this case, we're saying how many times does 3 go into 2, right? We'd say 3 goes, well, it can't. So how many times does 3 go into 28? Okay, so that's what we're looking at first, right? We're looking at the 3 and the 28, and we're saying how many times does 3 go into 28, and whatever I get for that, in this case it's 9, that's how many times it goes in without going over. So I have the 9 there, and if I ask people, okay, well, what do you do next? Most of the time people say, well, you subtract, which is right, except in your head, you're so used to the process that you're skipping a step. How do I know what to subtract? Well, that I get what I subtract when I multiply. So I'm going to multiply 3 times 9. Okay, so I multiply whatever number I just put up there times the divisor, and I put that answer here. And then I subtract. So in this case, I'm doing 28 minus 27. And then finally, I bring down the next number. So in this case, I bring down the 9. And then what I do is I repeat those steps 1 through 4. Okay, now in class, at least for one of the classes, I kind of had the step 1 split into 2 parts because I said divide and then write it up on top. So I had like 6 steps instead of 5. So don't get confused about that, okay? You'll see that's generally the same thing. So now what am I doing? Well, now I repeat that. Instead of seeing how many times 3 goes into 28, I'm seeing how many times 3 goes into 19. So 3 goes into 19 6 times. 6 times 3 is 18. Don't get confused with my little line there. Maybe I'll do highlighting instead, so it doesn't look like a division. So we see how many times 3 goes into 18. Let me fix what I just did there. Sorry, we see how many times 3 goes into 19. 6 times 3 is 18. I subtract, and then I bring down, and then I do it all over again. I see how many times 3 goes into 12. Now, when I'm trying to see how many times something goes in, there are 2 different ways I can think about it. I could think about it as 3 times what equals 12. Like, here's my missing number that I need to figure out. Or I could think about it as 12 divided by 3 equals what, right? Either way, I'll get that 4. I know that my divisor times that number on top, I want it to be this number that's highlighted or as close as I possibly can. In this case, 4 times 3 is exactly 12. I subtract, I have a remainder of 0, and there's nothing else to bring down. So in this case, my answer, or we call it the quotient, is 964, and my remainder is 0. All right, so we're going to think about that process, and that's what we're going to use when we do our polynomial long division. Okay, we're going to divide, we're going to multiply, we're going to subtract, we're going to bring down. So let's look at our polynomials now. Okay, so in this example, again, the first number, the dividend, is what goes inside my long division sign, and my divisor is what goes outside my division sign. So the first step again is to divide, to see how many times something goes into something else, but we're only using our first term in each polynomial. Okay, so I'm not looking at the whole thing, I'm just looking at that first term. And again, I could think of it 2 ways. I can either think x times what equals x squared, or I can think, okay, x squared divided by x equals what? Right? Either way, whether I think of it as like what's missing, or if I use the quotient rule, 2 minus 1 is 1, either way, this becomes an x up here. So there's my division. I'm going to put D here for divide. Okay, my next step is to multiply. So I need to multiply that whatever I just put on top times the entire divisor. Okay, not just the part I highlighted before, but the whole thing. So x times x is x squared, x times 5 is 5x. So x squared plus 5x, that's what I get from multiplying, and that is going to go right here. Now, I want to subtract this. That means I need to put it in parentheses because I have more than one term that I need to subtract. Okay, so I actually need to subtract it now. So x squared minus x squared cancels out. When we're doing polynomial division, that first term will always cancel out. Then I move on to the next term. I want to really carefully watch those signs. So I have -2 minus 5. So -2 minus 5, I could write it as -2 plus -5. That's going to be -7. And then finally, I bring down my next term, my -35. Okay, I've done all of those steps. This is where I go back and repeat those steps with the next section. So my next section here is -7x. So I want to know, okay, either x times what equals -7x, or I could write it as -7x over x. Either way, I'm going to get -7. So -7 goes here. I multiply. In this case, I'm multiplying -7 times x plus 5. So I get -7x minus 35, or plus -35, either way. So I write that here. Then I need to subtract the whole thing, put it in parentheses because I have more than one term. -7x plus 7x is going to be 0, and -35 minus -35 is like -35 plus 35, which also is going to be 0. So my quotient is x minus 7. My remainder is 0. If my remainder is 0, that means something goes in evenly. So 12 divided by 4 is 3 with a remainder of 0. 13 divided by 4 would be 3 with a remainder of 1. If I want to check this, I can multiply my divisor by my quotient, right? My divisor by my answer. And what we should get, I'm not going to take the time to multiply it right now, but we should get what we started with. Exactly, okay? If we had a remainder and we checked it, we'd have to multiply those two and then add in the remainder in order to get what we started out with. Okay, so I would suggest that you take a minute to kind of pause this and look through and make sure you understand how we did all of this. Once you've gotten a chance to do that, then let's move on to the next example. All right, so I'm going to put my polynomial, my dividend, my first polynomial, I should say, inside the long division sign. And my divisor outside. And again, I'm starting out, I'm just looking at the first terms. So if I take x cubed and I divide out x squared, or sorry, x, if I take x cubed and I divide it by x, I'm going to get x squared. So that is what goes up here. Okay, and again, I would suggest that you pause the video, try it on your own, and then come back, or even just try one step at a time. So pause it, do the step, and then wait and see if you got it right, and then move on. Okay, so that's our dividing step. Next, we multiply. So I'm going to multiply our answer, our quotient there, part of it, times my divisor. So I would get x cubed plus 3x squared. So that will go underneath here. Then I will subtract. X cubed minus x cubed cancels out. 8x squared minus 3x squared. 8 minus 3 is 5. Nothing too tricky there. So I have that, and then I bring down. Now, I often, in this case, bring down all of the rest of the terms, just so I kind of don't forget anything up there, but you can also just bring down one. That's fine. All right, so now I'm starting over with x and 5x squared. So in my division, I would have 5x squared divided by x. Well, 5 divided by 1 is 5. When I divide these two, I subtract the exponents and I get x. So it's a positive 5x here. Then when I multiply this, 5x times x is 5x squared, which is good because I should always get what I started out with there. And then plus 15x. So 5x squared plus 15x. I go to subtract it. I need to put it in parentheses to subtract. This cancels. 17 minus 15 is going to be 2x. And then finally I do this one more time. So 2x divided by x is just going to be plus 2, or you can think x times 2 gives us 2x. So now I multiply, write that right here. So 2 times x plus 3 is going to be 2x plus 6. So I put that here. 2x minus 2x is 0. That cancels out. 6 minus 6 is 0. Again, we have a remainder of 0. Not always going to happen, but in these it did. So our quotient is x squared plus 5x plus 2. If it specifically asks you for the remainder, you would put 0. Otherwise, if it doesn't specifically ask, if the remainder is 0, you don't have to include it. Again, to check it, you would multiply x squared plus 5x plus 2 times x plus 3. Okay, so last example here for long division. And there's something else that we have to bring in here, which we really always have to look for, but we didn't talk about it in the earlier ones because I wanted you to just get your feet under you in terms of dividing. So we have to fill in any missing terms with zeros. Okay, so here's what I mean by that. If I look at my dividend, and this can be in the dividend or the divisor, you might have to do this. When I look at this, the exponents, I have 3, I have 2, I have nothing, no term that's x to the first power. And then 4 is like x to the 0 power, right? So I'm missing this x to the first power term. So what I need to do then is have x cubed. I need to rewrite this. And in order to have x to the first that's not going to change anything, I just put in a 0. So x cubed minus x squared plus 0x to the first minus 4. It does not change anything, but it kind of puts it in as a placeholder. And the reason for that is if I look back at either of these other examples I did, when I went to subtract, you probably didn't even think about it before, but my like terms just kind of magically lined up. So when I looked at this, I had my x to the third over each other. I had my x to the second over each other. They lined up so I could subtract like terms. Then I had x to the second here over each other, and my x's over each other, right? And then my x's, and then my plain old numbers. So in each case, they lined up perfectly. Well, that won't happen if I'm missing this term, if I'm missing any of the exponents in line, okay? So that's why we have to do this. Now from here, we can move on just like we were doing it before. So we can have x cubed minus x squared plus 0x to the first minus 4. On the outside, I'm going to have my divisor, which is x minus 2. And then I'm going to go ahead and just look at the first terms. Okay, so I would really suggest, now that we've gone through a few, pause the video, try to do a couple of a couple of steps on it, and then come back, okay? All right, so x cubed, I'm dividing the x. I'm going to get x squared, so that's what goes up here. And then I multiply. X squared times x minus 2 is going to give me x to the third minus 2x squared. And now I subtract with my parentheses. X cubed minus x cubed cancels out. So I see a lot of negatives here, so I'm going to write this out. Remember, there's a 1 in front of the x squared. So negative 1 minus negative 2 is like negative 1 plus 2, which is 1. So I get 1x squared here. I don't have to write the 1. And then I bring things down. So I'm going to bring down everything. You can just bring down the 0 if you want. All right, so now I'm looking at x and x squared. So x times what equals x squared? Well, positive x. Then I have to multiply x times x minus 2. So I get x squared minus 2x. So I have here x squared minus 2x. And this is where this 0 that we added helps us out. If we hadn't added that as a placeholder, I'd have a negative 4 here, and I can't subtract 4 and negative 2x, and it would have gotten a little messy. So this just helps you keep that in line. So x squared minus x squared is 0. Here I have 0 minus negative 2, which is like 0 plus 2, which is 2. So 2x. Bring down the minus 4. And I do this one more time. 2x divided by x is 2, or you can think x times 2 gives me 2x. 0 here, not a 6. 2 times x minus 2 gives me 2x minus 4. 2x minus 4. Subtract, that cancels out. Negative 4 minus negative 4 is negative 4 plus 4, which is 0. Okay, so my quotient is x squared plus x plus 2. Okay, so we've talked about two different situations with division. In the first one, we're dividing by a monomial, by one term, and we can just write it out as separate fractions and go from there. The second one is if your divisor has more than one term. Then I have to do long division. Now my third type is kind of optional in that long division will work for any problem where that divisor is more than one term. Okay, long division will actually work for those easier ones also. Long division will work for anything. Synthetic division is sort of a shortcut, and it works when the divisor is in the form x minus c. Okay, which can be a plus or a minus there. So for example, if my divisor is x minus 2 or is x plus 5, that both counts. Those both count, okay? So just x and a number, no x squared, not more than 2 terms, okay? So in that form. All right, so let's first use long division to find this quotient and remainder, and then we're going to kind of compare long division with synthetic division. So I put my dividend in here. I look first, it doesn't have any missing terms because my exponents go 3, 2, 1, 0. So I'm okay. Okay, and then I have my divisor out here again, just to help us keep track of where we are. I'm going to highlight those two. X times what is x cubed? It's going to be x squared. Then I multiply that, so x squared times x is x cubed. Minus 2x squared. I subtract, this cancels out. Now be careful here, it's 2 minus negative 2. That's like 2 plus 2, which is 4. And then I bring this down. And then I do it again. So 4x squared, x goes in there how many times? It's going to be 4x. Okay, and you can, again, do the work off to the side. I'm going through this a little faster because just kind of to get us into the synthetic division. So 4x times x is 4x squared. 4x times negative 2 is minus 8x. This is going to cancel out. Negative 7 plus 8 is 1. And then I just brought that 5 down. Then x times what is x? Well, it's just positive 1. So 1 times x is x. 1 times negative 2 is negative 2. Again, we subtract. This cancels out. 5 plus 2. This time we do have a remainder. So our quotient is x squared plus 4x plus 1. Our remainder is 7. Okay, so we know that's one method to do it. That's our long division. Okay, we are going to now use our synthetic division, and their steps are, if you look below here, the steps are all written out here. It's very wordy, and so we're going to go through it first as an example and then look at the steps. Okay, so the first thing I need to do is it's written a little differently, and I just include the coefficients. So I don't have to write out the whole polynomial, and we kind of write this little box the opposite way. So in this box, we're going to need space for 2 rows, okay, and then a row below it. So across the top, I'm going to put just my coefficients. And again, I would need to put a 0 if I were missing one, but I'm not. We already checked that before. So I have a 1, a 2, a -7, and a 5. And I just kind of list them out, but far enough apart that I can tell it's like a 1 and a 2, not a 12. Now, what goes on the outside is part of my divisor. So remember that I said I wanted this in x minus c as my format for my divisor. Well, I need to think about whatever c is. So in this case, c is 2. All right, so I am going to put c, or just 2 here. And then I'm going to start out by bringing this 1 straight down here. And then the 2 words that I'm going to tell myself are multiply and add. Okay, those are the 2 words we're going to use over and over and over. So I'm multiplying this bottom number of 1 by the divisor part 2. So 1 times 2 is 2, and it goes right here. And then I add these 2. 2 and 2 is 4. And then I multiply. 4 times 2 is 8. And then I add. -7 plus 8 is 1. And then I multiply. 1 times 2 is 2. And then I add. 5 plus 2 is 7. And that's all I have to do. And what I end up with here is this bottom row is going to tell me my answer. So when I look at the bottom row, let me actually start with this other side here. We'll use this color. The last number is my remainder. And everything in front of that is my quotient. Okay, so these are the coefficients of the quotient, right? So this is my remainder. It's just a plain number. When I count over, this is x to the 0, or just a constant. This is x to the first. This is x to the second. I'm always going to start with x to the 0 for the rightmost number, and then just count over so I know what the exponents are. So this tells me that my quotient is x squared plus 4x plus 1. And then I have a remainder of 7. Now, how do I know it was plus in here? It's because those are positive. If they had been negative, it would have been minus. So let's look at the long division and the synthetic division. Okay, obviously we got the same answer. And if we look hard in between, a lot of the numbers are actually, the same numbers are in there as well, okay? So if I look at this, I have this 2 here. Well, I have the 1 also, but I have this 2. It's a little easier to see. That's my 2 here. So here's my 2 above it, and then minus -2 is like plus 2, right? And that gives me the 4. And then I have a -7 and a +8. Well, here's my -7 and my +8, okay? And then here I have a 5 and a 2. Here's my 5. Here's my +2. So we have the same numbers. There's my 2. This 1 right here is this 1 in front of that x cubed. It's the same numbers. The reason we subtract in one and we add in the other only because of the sign here. This is -2, and we've switched it to just the 2 on the synthetic division. But it's the same idea, okay? So you can use synthetic division instead of long division as long as your divisor is in that form of x minus c. So x minus a number or x plus a number. So if we look at the steps, it said write out the coefficients, Write out the value of c, that's where we put the 2 on the outside. Bring the leading coefficient down to the third line, we brought that 1 down. And then we multiply, we multiply that leading coefficient by c, and then we add, right? And this just kind of explains where it goes, which you saw when we did it. And repeat the steps until you have used all the coefficients. The quotient, so the remainder is the last third row number, and the quotient uses all of the third row numbers except for the last one. Okay, so let's try this synthetic division with this one. So I have x to the fourth, third, second, first, and a constant. So I do not need to put any zeros in. So I'm going to write my little box here, and I have my coefficients 2, -1, -38, 16, 103. Now, if I look at this divisor, I have x plus 4, but I need this in the form of x minus c. So I can think of this as x minus -4, right? Then my c is -4, because now everything matches up. So I'm going to have a -4 out here as my divisor part. So this first coefficient comes all the way down, and then remember our two words are multiply and add. So multiply, add, -4 times -9 is positive 36, and then I add and I get -2. -4 times -2 is 8. Add that, I get 24. 24 times -4, well, let's see what that is. 24 times 4 is 96, so I'm making it negative, so -96. 103 minus 96 is going to be 7. So this is my quotient, and this is my remainder, right? So remember, this is going to be x to the 0, x to the first, x to the second, x to the third. So my quotient will be 2x to the third minus 9x squared minus 2x plus 24, and my remainder is going to be 7. Okay, in order to check that, I could multiply my quotient by my divisor by the whole x plus 4. Whatever I get, then I'd have to add in that 7 from the remainder to get what I started out with. Okay, so there are a couple other, let's see, we have several other examples here, don't we? All right, so we're going to do the second example. So we're going to use synthetic division, okay? Now we could use long division, right? But because this is x plus or minus just a number, no x squared, we don't have to. If I look at this, I see that I am missing an x squared. So I need to put in a 0x squared. So I'm going to have x cubed plus 0x squared minus 7x plus 6. All right, so what I'm going to do is write out my little format here for my synthetic division. I put in just the coefficients, so 1, 0, -7, 6. And you might have caught also up in the steps, it mentioned that the degree of your answer is going to be 1 less than the degree that you started out with of your dividend. So what does that mean? Well, your degree is your highest exponent. So if this degree is 3, my highest exponent here is 3, so my highest exponential expression is x to the third, then I already know that my answer should have x squared as its highest. Okay, so that kind of just gives you an idea of where you're headed. All right, so I'm going to now figure out what my c is. Well, again, x plus 3, if I want a minus, it's going to be x minus -3, x minus c, so my c is -3. So -3 goes in here. -3 times 1 is -3. I'm going to add, I'm going to multiply, I'm going to add, I'm going to multiply, and then I add. So in this case, I have a remainder of 0. Here's my quotient, again, x to the 0, x to the first, x to the second, and as we saw, it does end up 1 degree lower. So my quotient is then going to be x squared, or 1x squared, minus 3x plus 2. My remainder is 0, so if it asks for it specifically, I can give it, otherwise I don't have to. Okay, now one thing also, sometimes, let me go back up to the previous one. Sometimes when you're asked to give the answer, it will want you to give the remainder as part of a fraction. So another way to give the answer here is 2x to the third minus 9x squared minus 2x plus 24. There's my quotient. Plus 7 over x plus 4. Okay, so it's the remainder over the divisor, right? It's part of another one of those. We don't have a full other grouping. That's why we have a remainder. So it's that over the divisor. Okay, so you may see that also. All right, let's look at these other examples. There are 3 more examples, I think 4 more examples that are for long division and synthetic division. Okay, so example 1, you can use either method because of the way that divisor is. It's x plus or minus a number. Example 4, you have to use long division for this one. You have to, because it's 3x plus 1, not just x plus 1. Example 5 can be either one. Example 6 can be either one. Okay, so go ahead and try those. I'll do them on here. I'm going to just have the answers up so you can pause the video, try them, and then just check your answers. And I'll do them both ways for the ones that can be done both ways so that you can check your work there. Okay, so here are the solutions to these. For 3, 5, and 6, I did it both ways. For number 4, it had to be long division, so I just did it with long division. So I would suggest that you check your answers, pause the video, check your answers, and then, kind of see if there is a discrepancy between your answer and mine, see where the mistake might be. And, if you're not sure, if you see what's different, but you're not sure why it's different, then just make a note by it. And then that's a great thing to ask me about in office hours. Most of the time when someone gets kind of off track with long division, especially, and with synthetic, but mostly with long, it's a sign error. So maybe when you're subtracting, negative x to the fourth and minus negative x to the fourth, you're doing plus instead of minus. That's most of the time. Now, example 3 is a little bit unusual because we have all these zeros. So when I subtract, I get 0. I have to put something up on top whenever, once I've subtracted, I have to figure out what goes up on top, right? So I subtracted, I brought down. Now I have to figure out x goes into 0 how many times? It goes in 0 times. So then I kind of just multiplied that and subtracted. It doesn't really change anything, right? And then, so that happened a couple times, and it ended up with these zeros, and you can see the same thing happened in synthetic division. And that just means there's no x cubed and no x to the first terms, okay? So that's the first one. So you can pause the video if you need more time to look at that. The second one, let's get my cursor going here. There we go. So the second one, we had to do long division because of the 3x plus 1. So you can pause the video to look through that one. Then 5, we're back to being able to do it either way. This was a relatively short one. And then in 6, so again, if you need more time in 5, just pause the video. And then in 6, notice we're missing an x to the first term, so we put in a 0 there in both versions, and then we get our answer there. Okay, so any questions on this, please make sure that you contact me.